All right, if you're looking for 30 seconds worth of content, this is not the video. This is probably going to go a little long. We're going to do a supplementary essential variables YouTube short, and I'm going to try and keep it as short as possible. So anyway, supplementary essential variables are conditions which a change affects the toughness properties. This is how much of a beating the material can take at a specific temperature. And this includes the heat affected zone or the base material or the weld metal. So some examples of supplementary essential variables would be group number. If we change our diameter, this is for stick welding, to anything over of 1/4 of an inch or 6 millimeters. The heat input, or if we change position when we're welding, and this is for the process. This is not for the person. This is for the process when we're talking about change in position. So when we're talking about P numbers are groupings of materials that have the similar weldability. And we don't really worry about it too much. We do, but we really get nitpicky about this when impact testing is required. So impact testing is when required, and it'll be a code and or engineering will call it out. But this is generally comes into play when we're at a colder temperature, because steels react differently at colder temperatures in regards to how hard we can hit them and what amount of abuse they can take. So we have group numbers. It's like a P number would be like a state, and a group number would be a county. So we further break P numbers, which is, let's say for carbon steel, we'd have different groupings. And these groups are going to react differently. Like North Texas has different weather than South Texas. So there's some nuance to this in regards to metallurgy and how much of a beating these materials can take. So when we're talking about the diameter, if we go anything, if we qualify our weld procedure with anything under 1/4 of an inch diameter for shielded metal arc welding, I'm using shielded metal arc welding for this example, and we go to a filler material that's larger than 1/4 of an inch, we got to requalify. This becomes an essential variable. It's a supplementary essential variable. When we're talking supplementary essential variables, these are variables that we ignore until impact testing requirements are invoked either by the code or the engineer. Heat input. This is how much thermal energy we're pumping into that material. And if we put too much heat into it, there's a chance that we could alter the microstructure and or the mechanical and physical properties of the base metal, heat affected zone, and the weld metal. So a lot of times, well, when we do impact testing, we will measure the travel speed, the amps, the volts, and it'll give us the amount of thermal energy in kilojoules that's going into that weld metal. So we have to monitor this. If there's, depending on what code we're working with, if there's a change in the heat input, we're going to have to requalify, because this is going to change our material properties of the weld metal, base metal, and heat affected zone. If we change positions, if we go from the flat position to a vertical uphill progression, this is going to put way more heat into our weld than if we're just running flat. And a change from stringer bead to a weave bead. So if we qualify our WPS, our PQR, with a stringer bead because we're traveling faster to a weave bead, we're putting way more heat into the material. So, and this doesn't apply if we're going to do austenitic stainless steels and we're going to give it a solution anneal. I tried to stuff 7 pounds of stuff into a 3-pound bag in this video. Still trying to adapt to this format. Hey, if you got any questions, like and subscribe, shoot me an email. You can track me down at texasweldingengineering.com. Thanks for watching.